Hello everyone. In the redox chemistry, today's topic is disproportionation reaction and comproportionation reaction. So let us see what about disproportionation reactions. Disproportionation reactions are such redox reaction where one substance, some element within a compound changes into two different species, and their oxidation number in one of the species increases and in other species it decreases. So these types of reactions are called disproportionation reaction. So what is the definition of disproportionation reaction? The definition of disproportionation reaction is the chemical changes in which an element is converted into two oxidation states, one higher and another lower than its existing oxidation state. This is called disproportionation reaction. So the existing, let us elaborate with some examples here. So in the first example, you have cuprous sulphate. The oxidation state of copper is +1 here, and when it is decomposed into metallic copper and cupric sulphate, then in the metallic copper the oxidation number is reduced by 1, that is it is decreased by 1, and it becomes from +1 to 0. On the other hand, another species formed, it is cupric sulphate, where the oxidation number of copper increases from +1 to +2. So both oxidation and reaction taking place in the same species. So this is a very good example of disproportionation reaction. Let us see what about in the other examples. This is an acid catalyzed disproportionation reaction where manganate ion getting oxidized and reduced both to form, first of all, permanganate ion into permanganate ion, and secondly into the manganese dioxide compound. So when it is manganate ion, the charge is -1 here, -2 here, and when it is permanganate ion, the charge is -1 here. So it is very easy to calculate the oxidation number in manganese, which is +6 in manganese in the existing oxidation state, and on the other hand, when it is converted into permanganate ion, then its oxidation number is increased by 1 and it becomes +7. And another species which is actually getting reduced to form manganese oxide, here the oxidation number of manganese is decreasing by 2. So it is decreased from +6 to +4. So this is a very good example of a disproportionation reaction where manganese changes its oxidation number in both ways. It is getting oxidized, it is getting reduced. Now white phosphorus, when reacts with very strong alkali like sodium hydroxide, then it produces phosphine gas and sodium hypochlorite. This compound is sodium hypochlorite. Hypophosphite. So phosphorus reacting with sodium hydroxide in presence of water, it produces phosphine and sodium hypophosphite. Okay. Now let us see what about the oxidation numbers of phosphorus in white phosphorus first. So oxidation number of P is 0 in P4. On the other hand, in phosphine it is -3, and in sodium hypophosphite it is +1. So in phosphine its oxidation number is decreasing by 3. So from 0 it changes to -3. On the other hand, in another species which is formed from phosphorus, the oxidation number of phosphorus P is +1, that is it is increasing by 1 from 0 to +1. Next example, decomposition of potassium chlorate. When potassium chlorate decomposes, it forms potassium perchlorate and potassium chloride. So when potassium perchlorate is the existing compound, there the oxidation number of chlorine is +5. Now when it is converted into potassium perchlorate, then the oxidation number of chlorine is increasing by 2 and it becomes +7. On the other hand, when it becomes potassium chloride, that is it is getting reduced, chlorine is getting reduced, then its oxidation number decreases by 6 from +5 to -1. So the oxidation number is decreasing by 6. Okay. In the next example, we have decomposition of hydrogen peroxide. In hydrogen peroxide, the oxidation number of oxygen is -1. So it forms water and oxygen. Within water, the oxidation number of oxygen decreases by 1 and it becomes -1 to -2. On the other hand, the second species is oxygen molecule, where the oxidation number of oxygen, that means O, is 0. That means oxidation number of O is decreasing from -1 to 0. That is, it decreases by 1. And last and final example, when chlorine gas is passed through sodium hydroxide, then it forms sodium chloride and sodium hypochlorite. This is sodium hypochlorite. Okay, so this is found in the this is actually used in the zeolite in disinfecting water, in purifying water. Okay, in the medicine shop you will find zeolite. There sodium hypochlorite is used. Okay, so this is sodium hypochlorite. It is produced simply by passing chlorine gas into the sodium hydroxide solution. So the oxidation number of Cl in Cl2 is 0. It decreases by 1 in sodium chloride, where it is -1, and increases by 1. It is +1 when it forms NaOCl. So these are the examples of the disproportionation reactions. Now we have to verify whether these reactions are thermodynamically favorable or not. That means their delta G value are negative or not. So let us take the example of cuprous ion, which is getting oxidized to form cupric ion and getting reduced to form copper metal. So the standard electrode potentials are respectively -0.15 volt and +0.50 volt. So from the next equation we can calculate the free energy change as, for the first reaction, for the oxidation reaction, the -0.15 volt contributes to the free energy change as +0.15 Faraday. On the other hand, the reduction reaction has delta G value -0.50 Faraday. So what is their summation? Their summation is overall -0.35 Faraday, and the reaction, the overall reaction is, you just add this equation with this equation, then you will get 2 cuprous ion to get 1 cupric ion and 1 metallic copper, and the overall delta G value is negative here. So this is thermodynamically favorable. So within the solution you will see a disproportionation reaction of copper, and copper plus Cu plus, that is the cuprous ion, is only isolated when it is in the solid state. Okay, in the solid you can get Cu2SO4. Okay, but if you dissolve Cu2SO4 in water, then it forms and then copper is getting precipitated. So sometimes the question comes where if you add cuprous sulphate in water to form an aqueous solution, then why does copper precipitate it out? Okay, so this is the explanation. Now let us see in another example where the permanganate ion getting oxidized into where the manganate ion getting oxidized into permanganate ion and reduced into manganese dioxide. This reaction is actually H plus catalyzed reaction, and you see the order of the equilibrium constant here is 10 to the power 58. So it is highly favorable reaction. This is thermodynamically very much favorable, and this reaction definitely takes place in presence of acid. Sometimes it takes place in presence of simply neutral solution, in the neutral solution, and sometimes in some cases even in weakly basic solutions also. Okay, only you can isolate manganate ion, you can get manganate ion when it is present in strongly alkaline solution where the pH is greater than 14. So this is pH is greater than 14 means the concentration is definitely more than 1 mole. Okay, so this reaction, the equilibrium constant is of the order of 10 to the power 58, and disproportionation occurs in acidic, neutral, or even slightly basic solutions. And the manganate ions may exist only in strongly alkaline solutions where the pH is greater than 14. Okay. Now come to comproportionation reaction. This is actually the reverse of the disproportionation reaction. Okay. So you find the examples here. You can see the examples here where +2 silver and 0 silver combine to form +1 silver. On the other hand, in the same compound, nitrogen is existing in two oxidation states, -3 and +3. They combine with each other to form oxidation state of nitrogen, where oxidation state of nitrogen is 0. So what is the definition of comproportionation reaction? The reverse of disproportionation is comproportionation, where an element in two different oxidation states unite to form a product of that element in an intermediate oxidation state. So these are the examples. So that's all for today. That's all for comproportionation disproportionation reaction.